This is Group 6. We are working on a project that helps to protect people from reckless drivers. The project's name is Semi-Autonomous Responsible Driving Enforcement System. There are 5 members in our group: Joshua Pothola, team leader, computer science major, responsible for video encoding system; Andrew Trainer, computer engineering major, responsible for video encoding system; Michael Lopez, computer science major, responsible for back-end; Sarah Rangel, computer engineering and computer science major, responsible for front-end; Lộc Huỳnh, electrical engineering major, responsible for weather system and power delivery network.
Hi, my name is Sarah Ranger, and next I'll be quickly going over Group 6 project goals. The first one being increasing neighborhood safety by mitigating the severe impact that reckless driving has on our society. Second is to support the law enforcement by identifying unique cases of reckless driving without the need of any input from a human being. And the third one is to detect the presence of cars, license plates, and pedestrians and locate them within the current video frame. Also, our next goal would be to detect weather conditions at the time of the reckless driving incident. And once we collect all this data, send the collected data to the end user for further processing. Our last goal was not a requirement, but we wanted to ensure our system was eco-friendly.
Hello, my name is Andrew Trainer, and I'll quickly be going over some of the goals that were achieved during the project period. Real-time object detection for the presence of cars was completed as a task. Tensor RT optimization for deep learning applications was utilized for optimizing the detection graph of the model. Estimation of vehicle speed through frame processing was completed as a task, and we were able to establish a rough estimate of whether a vehicle was speeding or not. In the case that the vehicle was speeding, we were able to encode a vehicle image and save an image of the reckless driver. The weather subsystem completed the tasks of detecting the weather conditions at the time of the incident via sensor data. We are able to ensure that the system is eco-friendly and uses solar power when necessary. Utilizing a server and client subsystem structure, we are able to display the collected data to the end user in which they can view all the incidents of reckless driving.
So, with that being said, let's go over our system. Here we have the physical components of the system. A wind, temperature, and humidity sensor are connected to a microcontroller to collect local weather data in real time, which will be used to determine whether the weather is poor. A camera intended to be pointing at a major road, intersection, or highway, and a system on module, which will take the collected information and determine if a car is speeding. Together, they all make the camera unit. To demonstrate how the system works, we've hooked up a monitor to the camera unit. Displayed on this monitor is a representation of what the camera unit sees, as well as how it works and what it's thinking. When a car crosses this ROI line, its speed will be captured and determined using machine learning graph. Also, every half minute, the camera unit will collect new weather data and update whether or not it thinks the weather conditions are poor. If so, it will trigger its speeding detection at a lower threshold, since we expect cars to slow down when bad weather conditions are present. When a car is found to be speeding, it is sent off to a central server, along with the weather data, current time, and an image of the car. Also involved in this system is a custom-made desktop client intended for law enforcement to use to receive information about these speeding cars. As you can see, as soon as a car is detected, the client immediately gets a notification. When the user clicks on the car, it receives detailed information about the infraction, including the weather, speed, and direction, and a timestamp. It is entirely up to law enforcement as to how to act upon this information.
Alright, so we have the application starting up again on the Jetson Nano. This time we'll be using a pre-recorded video so that we can better show how our host system is put together. On the left hand side you can see the Jetson Nano, and on the right hand side of the screen you can see the client application. So this client application was built using Electron, and it is a single page web app using JavaScript, HTML, and CSS, and then packaged using the Electron Forge tool. For purposes of this demo, we lowered the speed limit so that we can grab more vehicles and save these so that we can show how it is displayed on the end user side. So as you can see, the video feed popped up now. So the way our application works is every time a vehicle passes through the ROI line in the middle, it will analyze this vehicle, and if it is determined to be reckless, we will save the information on this vehicle, such as the direction it was going on, uh, what speed it was going, what type of vehicle it is. We will also record the weather data at that particular instance using our sensors, and we will take a snapshot of the vehicle. This information gets packaged into a JSON object and then gets sent over to the server, which is then saves it and sends it over to the client in real time using a socket. Once this information is in the client, the user can see the list of vehicles saved and expand on the data on that vehicle. So there you can see the type of vehicle, what violation it was, the weather data, and what direction it was going in and speed. So if the user does prefer a different format, they can save this list of vehicles as an Excel spreadsheet if they do prefer that. Some challenges we had with this application was being able to detect multiple instances of reckless driving at the same time. So right now a vehicle has to pass by that ROI line to be able to analyze the vehicle. So it would be much better if a vehicle can be anywhere on the screen and detect it there. Another challenge we had was being able to save video clips of the instances of reckless driving. So currently we only save a snapshot of the vehicle, but it would prove much more useful to have a video of the instance. That way the end user can determine if a vehicle is actually driving reckless or not, and then do any appropriate action on their end.